Somewhere out past Jupiter right now, there's a visitor moving through our solar system that has no business being here and no way of ever coming back. It arrived from outside everything we call home. And when scientists finally got a good look at what it was actually made of, several of them used the same word in their published papers: puzzling. Not once, repeatedly. This is the story of what the James Webb Space Telescope found when it turned its mirrors toward a comet that doesn't chemically make sense. I'm Arif Hassan, and this is History. It started on July 1st, 2025, at a small observatory called Atlas in Rio Hurtado, Chile, whose entire job is scanning the sky every night for anything heading toward Earth. That night, it caught a faint point of light moving in a way nothing in its catalog matched. Within days, astronomers confirmed the object wasn't looping around the sun the way every comet and asteroid in our solar system does. It was moving on a hyperbolic path, the kind of wide-open arc that only makes sense if something arrived from outside the sun's gravity entirely and is just passing through. It was named 3I/Atlas, the third confirmed interstellar object in history, after Oumuamua in 2017 and Borisov in 2019. Later analysis found faint traces of it in older sky survey images going back 55 days before its official discovery, sitting unnoticed in the data the whole time. When it was found, 3I Atlas was already moving at roughly 137,000 miles per hour, still well outside Jupiter's orbit. That speed alone told researchers this wasn't a local object. Something had accelerated it long before it ever encountered our sun. By October 2025, astronomers had worked out its orbital eccentricity at roughly 6.1, making it the most extreme, least bound trajectory of the three interstellar visitors humanity has ever confirmed. It's worth knowing how different those three actually are. Oumuamua tumbled through its brightness cycle, suggesting an elongated, cigar-like shape, showed no visible tail at all, and displayed a faint acceleration that couldn't be fully explained by gravity alone. Borisov behaved much more like an ordinary solar system comet, with a conventional tail and familiar chemistry. 3I Atlas doesn't fit either template. It has an obvious active coma, like Borisov, but a chemical fingerprint and an age that put it in an entirely different category. Hubble got the first real look on August 20th, 2025. It couldn't see the solid nucleus directly through the surrounding coma of gas and dust, but by modeling that glow, astronomers bounded the icy body's size somewhere between roughly 440 meters and 5.6 kilometers across, an enormous range that reflected just how little prior data existed for comparison. Then came the part that actually surprised researchers. As 3I Atlas moved closer to the sun and warmed up, Webb and NASA's SphereX mission examined the gases pouring off it. In a typical solar system comet, water vapor dominates. Here, the coma was roughly 95% carbon dioxide, with only a small fraction of water and cyanide emission mixed in. A carbon dioxide-dominated coma like that suggests the object formed somewhere extremely cold, colder than where our own solar system's comets condensed. Researchers who published this detection as a preprint in late August 2025 described it as evidence the comet came from a formation environment very different from our own solar neighborhood. The age of this thing took nearly a year of follow-up work to pin down. Early estimates, based on its orbit and the surrounding stellar population, suggested around 7 billion years old, already older than our solar system. The firmer confirmation came from Webb's spectrographs, observing the comet on August 6th and again in mid and late December 2025, after it had swung past the sun. A team led by Martin Cordner at NASA's Goddard Space Flight Center measured the ratio of two carbon isotopes, carbon-12 and the heavier carbon-13, a ratio that shifts gradually across cosmic time as generations of stars enrich the galaxy. What they found contained far less carbon-13 than anything measured in our solar system or nearby young planet-forming disks. Working backward through galactic chemical models, they concluded the object likely accreted its ice somewhere between 10 and 12 billion years ago, during an early, intensely active period of star formation astronomers call cosmic noon. Our solar system is about 4.6 billion years old. The universe itself is roughly 13.8 billion. This comet may have been drifting through interstellar space for longer than the Sun has existed. The results were published in Nature in June 2026, and Cordner told reporters it might be the oldest object ever observed passing through our solar system. Webb also found the water it released was significantly enriched in deuterium, a heavier form of hydrogen, compared to typical solar system comets, a signature that tends to form in extremely cold environments, consistent with an ancient, frigid origin in what's called the galaxy's thick disk, an older, more scattered stellar population than the one our Sun belongs to. That's already a lot, but here's the part that pulled 3I Atlas out of specialist journals and into mainstream headlines. In October 2025, a team using the Very Large Telescope in Chile detected a plume of nickel gas coming off the comet, later corroborated by the Keck 2 telescope in Hawaii. Nickel vapor alone isn't shocking. It's been seen in a handful of solar system comets, including Borisov. What made this different was what was missing. Nickel and iron are forged together inside dying stars, and normally travel through space bound to each other, sometimes called cosmic twins. In 3I Atlas, the nickel signal was strong and iron was nearly absent, decoupled in a way that hadn't been documented in a comet before. Comets are generally far too cold at these distances for solid metal to vaporize directly. The leading natural explanation researchers have proposed involves a nickel-bearing compound called nickel tetracarbonyl, which can break apart and release nickel atoms under much weaker sunlight than would ever free iron from its own more stable compounds. If that mechanism holds up, it would represent a previously undocumented class of natural comet chemistry, not evidence of anything built. Researchers have also noted a much fainter version of the same nickel-dominant pattern in Borisov, suggesting this might be a real feature of comets formed outside our solar system generally, rather than something unique to this one object. Harvard theoretical physicist Avi Loeb, who has spent years searching for potential signs of extraterrestrial technology, has pointed out that nickel without iron is otherwise mainly associated with industrial refining processes on Earth, and has raised, publicly and repeatedly, the possibility that this could indicate something artificial. It's important to be clear that this is a minority position. The overwhelming majority of astronomers working on 3I/Atlas, including the teams who made these detections, favor natural chemical explanations rooted in the comet's unusual, ancient, extremely cold formation environment. A team also pointed the Allen Telescope Array, a radio observatory built specifically to search for potential artificial signals, directly at 3I/Atlas during its passage, in a genuine peer-reviewed technosignature search. The result was a clean non-detection. No artificial radio signal at any frequency the array could monitor. The comet reached its closest approach to the Sun on October 29, 2025, passing about 203 million kilometers away, just inside Mars's orbit. Before that, on October 3, 2025, 3I/Atlas itself passed near Mars, close enough that multiple Mars orbiters and NASA's Perseverance rover captured images of it, the closest any spacecraft had gotten to an interstellar object. It passed near Venus in early November, made its closest approach to Earth on December 19, 2025, at roughly 270 million kilometers, well over 700 times the distance between Earth and the Moon, and NASA and the European Space Agency were both explicit throughout that it posed no impact risk at any point. It passed near Jupiter in March 2026, and by around June 2026, Webb had picked up its first mid-infrared detection of methane on the object as it continued fading from view. Here's why any of this actually matters beyond the headline. Every comet in our own solar system formed from the same disk of material that built the planets, so studying them mostly tells us about our own local chemistry. 3I/Atlas is a direct physical sample of material that condensed around a completely different star at a different point in the galaxy's history and drifted here across billions of years undisturbed, until now. The nickel-iron anomaly specifically is forcing cometary scientists to reconsider assumptions about how metals behave in ice at extreme distances from any star, assumptions built almost entirely on a sample of solar system comets. It's not a discovery that rewrites physics. It's astronomers getting their first real outside data point. And outside data points are how you find out which of your assumptions were just local habits all along. 3/Atlas is still out there right now, somewhere past Jupiter, moving away at more than 60 kilometers a second, carrying chemistry that was locked into ice before our sun had finished forming. It will never slow down, never turn around, and never pass this way again. Scientists at the newly operational Vera Rubin Observatory in Chile expect to find many more objects like it in the years ahead, possibly dozens over the coming decade. The 3 we've confirmed so far are almost certainly not rare. We simply lacked the technology to notice them until the last decade. Somewhere out there tonight, a 4th interstellar visitor is likely already inbound, and nobody on Earth knows it yet. If you're finding stories like this genuinely interesting, follow the channel and drop a comment telling me what you make of the nickel anomaly. Share this with someone who'd get a kick out of it too.